Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to find the slope and y-intercept of a function from an equation, how to graph linear functions using slope and y-intercept, how to graph linear inequalities using slope and y-intercept, how to use the correct line and shading for graphs of inequalities, and how to graph multiple linear inequalities on the same plane and find their intersection. How are we learning it? Through the Systems of Linear Inequalities Review Notes and the Systems of Linear Inequalities Review Assignment. When can we use this information? To calculate the amount of money in a savings account, to determine which scores you can receive on your final exam that will allow you to pass the course, and to determine how many of each kind of product you might need to sell to reach a goal profit. How do you know you learned it? By getting a score of 4 on the Systems of Linear Inequalities Review Assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Systems of Linear Inequalities Review Notes, and then I'll give you time to complete the Systems of Linear Inequalities Review Assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Systems of Linear Inequalities Study Guide and any incomplete assignments that you may have. Let's take a look now at the Systems of Linear Inequalities Review Notes. The notes begin with the learning goals and success criteria.
Now let's talk about slope. What is slope? Slope is a rate of change involving x values and y values. Slope is known as for being the change in the dependent variable over the change in the independent variable. Now what does that really mean? That really means that slope is the change in the y values over the change in the x values. So it's always y over x. And the next part you need to know is the y-intercept. The y-intercept is the point where the linear function crosses the y-axis. So we have a line here, and we can see that the y-axis goes here. So where do they intersect? Well, they intersect right there. That is what we call the y-intercept. So in this case, our y-intercept would be 2. Slope-intercept form. Slope-intercept form is written as y equals mx plus b. And what does that mean? M is the slope, and B is the y-intercept. Y and x are my variables that stay variables so that I can plug numbers in and see what they come out to be. So M is the slope, and B is the y-intercept. Now, how can I remember that? The easiest way I remember this is M represents the slope because it's a slippery slope to get hung up on your x. So think about it in terms of relationships. People that are involved in relationships and they break up, there's usually that one person in that relationship that's always hanging on to the relationship that's already dead. That's the slope. That's M. It's a slippery slope to get hung up on your ex. They are not together anymore. But the M is always trying to hang on. Notice how close they are. So M is trying to hang on, and it's a slippery slope to get hung up on your ex. Now B, on the other hand, is alone, not attached to anybody. B is lonely, and lonely people ask the questions, why am I alone? Why does no one want me? Why does no one think I'm cute? That's B. B is always asking the why questions. Those are the y-intercept questions. So that's the way I remember it. It's a slippery slope to get hung up on your ex, and why am I alone? So that's the way I remember slope and y-intercept. Now, let's go ahead and pick out the slope and y-intercept from an equation. So we're given an equation, y equals 2x plus 4. And we want to know what is the slope of that line. Well, we know that the slope is the one that's attached to its x, right? So it's a slippery slope to get hung up on your x. So the one that's attached to the x in this case is 2. So the slope is 2. The y-intercept is the lonely one. Why am I alone? Well, the lonely one is 4, so my y-intercept is 4. So that's how I pick out the slope and y-intercept given an equation. Let's look at another example. We have y equals negative 3 halves x minus 3. Well, same thing. It's a slippery slope to get hung up on your x. So the slope is the one that's attached to the x, which is negative 3 halves. so that's my slope. And my y-intercept is the lonely one. Well, the lonely one in this case is -3. So B is -3. So that's how I find the slope and y-intercept from an equation. Now, how do I graph a linear function? Well, first thing I need to do is pick out my slope and my y-intercept. Well, in this case, my slope is -1/2 because that's attached to the x. Now, my y-intercept, notice there's nothing here. There's no lonely people. So how do I say none in math terms? Well, that's 0. So my y-intercept is 0. So now when I graph this, the first step is I plot the y-intercept. Well, my y-intercept is 0. So I'm going to go along my y-axis and find 0, which is right here. And I plot my point. The next step is I'm going to use the slope to plot my second point. Remember, this is change in y over change in x, or you might have heard it in the past as rise over run. We're going to talk about it as change in y over change in x. So my change in y is -1. So I go down 1. And my change in x is 2, so I'm going to go to the right, 1, 2, and plot my point. So now I have my first 2 points. The next step is just to connect the dots and draw a line between them. So I'm going to connect the dots. And now I have a linear function that is graphed that goes through 0 and has a slope of -1/2. There's a video here also that shows you how to graph linear functions in Desmos. So you can go ahead and watch that. Let's talk now about how to check our work with linear equations using Desmos. So what we're going to do is we're going to go to desmos.com, just like this, and we're going to click on the link that says Graphing Calculator. And over here on the left side, we can enter the equation of any linear equation, and it will graph it for us. So let's try y equals 2x minus 4. Well, as we can see, it graphs it for us. We can check that against whatever we did on our assignment now. And you can do it this way. Let's say we had an equation, though, that wasn't in slope-intercept form. We can still graph that on here and check our work. So let's say it was 4x minus 2y is equal to 8. And we can see that that's actually the same as this one. But we can look at this and check our work this way as well. It still graphed the equation in slope-intercept form, even though the equation we put in is not in slope-intercept form. So this is one way that you can check your work using Desmos to find linear equations. Well, with inequalities, we're going to graph them the same way. So just like we did before, we're going to plot the y-intercept, which in this case is -2, so I go down 2 and plot that point. Then I use the slope to plot the second point. Well, this is change in y, so we're going up 1 to the right 2. So we go up 1 to the right 2, plot my point, connect the dots, and now I have my line. Now the difference is we're going to shade where the y values are bigger than the line. So I'm going to look at the y-axis here, and I'm going to see where the line crosses, which is here, and I want all the y's that are bigger than that line. Well, they're all up here, so I'm going to shade that area up there above the line. So the shading is a new aspect of graphing that we need to consider. The other part is what kind of line to use. So similar to before where we talked about the open circle versus closed circle, same thing here. Every inequality gets a dotted line or an open line. Notice there, it's open because there's little spaces in between. So every inequality gets an open line or a dotted line. If they add more to the inequality, we do too, meaning if they add the bar underneath, then we're going to add to it and make it a solid line. So in this case, we have y is less than x. Well, I'm looking if they added anything extra, meaning that, did they add the bar here? If they didn't, which in this case they didn't, we'll leave it as it is and it stays as a dotted line. Now, here's an example of x is greater than or equal to 2. Now, they did add something extra. They added the bar here. So we'll add to it as well, and we'll make this a solid line or a closed line. So how does that apply to our inequalities? Well, when we graph these, we have y is less than 3/2 x. So we're going to plot the y-intercept first. Notice there is none listed here, so our y-intercept is 0. So I'm going to go here to 0 and plot my point. And my slope is 3/2, so I'm going to go up 3 to the right 2. So I go up 3 to the right 2, plot my point, and normally I would just connect the dots. But I need to check to make sure I have the correct line, which in this case, they didn't add anything extra, so I don't either, so it should be a dotted line. So there's my dotted line. Now I just need to shade it. So it says y is smaller than the line, so I'm going to go along my y-axis and find where it meets the line, which is here. And I want all the y's that are smaller. All of those are down here, so I'm going to shade everything on this side of the line. Let's look at another example. We have y is less than or equal to negative x minus 3. So again, I'm going to plot my y-intercept first, which is negative 3. So I go down 3 here. And my slope is just negative x, which really is negative 1. So that's negative 1 over 1. So that means I'm going to go down 1 to the right 1 and plot that point. Again, normally I just connect the dots, but I need to make sure I have the correct line. Well, they did add something extra, so we will too. So we're going to have a solid line. And now we just need to shade the graph. It says y is smaller than the line. So I'm going to go along my y-axis and find where they meet, which is here. And I'm going to look at all the y's that are smaller than the line, which are down here. So I'm going to go ahead and shade this area here. And that's how I graph the linear inequality. There's a video here that shows you how to check your work using Desmos after you've already graphed the linear inequality, so you can check it using Desmos. Let's talk now about how to check our work using Desmos when working with linear inequalities. So we're going to let Desmos graph linear inequalities for us so that we can check that against the work that we've done on our activities. So we're going to go to desmos.com and we're going to click on Graphing Calculator. And now we're going to go ahead and enter the inequality that we want to graph. So let's say it's y. Now to do the inequality symbols, we'll go down here to where it says keypad and click there. And here's all your inequality symbols. So let's say it's greater than or equal to. And then we can put in 3/2 x minus 5. And now it graphed the inequality for us. It shows the type of line right here and the shading. Now if it wasn't or equal to, we can see that it creates a dotted line, so it will create the correct type of line, and it will show the shading of where the shading should occur. So that's how you can use Desmos to check your work when dealing with linear inequalities. Now let's talk about how to graph a system of inequalities. So we're going to graph it just like we did the system of equations. So we're graphing both of them at the same time, and then we're going to find the overlap of the shading. So the first one says y is greater than or equal to negative 2/5 x plus 4. So we'll go ahead and plot our y-intercept first. Our y-intercept is at 4, so we're going to go ahead and plot that point. Our slope is negative 2/5, so we're going to go down 2 to the right 5 and plot our point. And they added something extra, so we will too, so we should have a closed line. And it's greater than, so we should shade above. So there's our first one. Then we'll do our second one. Our second one says y is greater than 5x plus 2. So our y-intercept is 2, so we're going to go ahead and plot that point at 2. And our slope is 5, so we're going to go up 5 to the right 1, right there. They did not add anything extra, so we won't either, so it'll be an open line. And it's greater than, so we'll shade above the line, so we'll shade just like this. And what we should notice is we have a blue area, we have a red area, and then we have this purple area. The purple area is the only area that actually matters. That is the part that is the overlap or the intersection. This is the only part that applies to both inequalities. Let's look at another example. We have y is greater than or equal to negative 2/3 x plus 3, and y is less than 3x minus 1. So we're going to plot the first one. So we'll plot our y-intercept at 3, so right there. And our slope is negative 2/3, so we'll go down 2 to the right 3. They added something extra, so we will too, and have a closed line. And it's a greater than symbol, so we're going to shade above. So there's our first one. Now the second one says y is less than 3x minus 1.
So we'll go ahead and plot our y-intercept at -1. And our slope is 3, so we'll go up 1, 2, 3, to the right 1. They didn't add anything extra, so we won't either. So it'll be an open line. And it's a less than symbol, so we'll shade below. So it'll be here. Again, we have a blue area, we have a red area, and we have a purple area. The purple area is the area that matters. That is the overlap of the two inequalities. Let's look at one more example. We have y is greater than or equal to -2x minus 3, and y is less than x. So we'll go ahead and plot the first one. So our y-intercept is at -3, so we'll go ahead and plot our point there. And then our slope is -2, so we'll go down 2 to the right 1 and plot our point. They did add something extra, so we will too. So we'll go ahead and have a closed line. And it's greater than, so we should shade above, so that's over here. So all of that should be blue. Now our second one, y is less than x. So there is no y-intercept, so it's really at 0. And our slope here is really 1, so we'll go up 1 to the right 1, plot our point. They didn't add anything extra, so we won't either, so it'll have an open line. And it's a less than symbol, so we'll shade below. So we shade down here, and we have our blue area, our red area, and our purple area, and the purple area is the intersection of the two inequalities. There's a video here that shows you how to graph systems of linear inequalities in Desmos, so go ahead and watch this video.
Let's talk now about how we can use Desmos to check our work when dealing with systems of linear inequalities. First thing we're going to do is go to desmos.com, which is here, and then we're going to go to where it says Graphing Calculator. I'm going to click on that. And on the left side, I can enter the two inequalities that I want to look at. So let's go ahead and put one in. Y is greater than 1/2 x minus 5. So there's my first one. And then I'm going to put my second one in. Y is less than 3x plus 2. Okay, and now we can see where we have our two lines that are drawn. They're both, in this case, dotted. Okay, but that could change depending on the sign. They're both dotted. And we can see that this area up here is all shaded in red. This area here is all shaded in blue. And this area is shaded in purple. The purple area is the part we care about. This is the overlap of the shading. So all of this area here would represent the solutions to the system of inequalities. So, and we could enter this in with any equations, any inequalities, and it will graph it for us and show us exactly where the solution should occur. So that's how you can use Desmos to check your work when dealing with systems of linear inequalities.
Let's take a look now at the Systems of Linear Inequalities review assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. The first one says, which of the following represents the graph of the inequality below? So y is greater than or equal to 1/2 x minus 4. So let's go ahead and treat it like it's an equal sign. So we should have a y-intercept at -4. Well, we notice all of them have a y-intercept at -4. And our slope is 1/2, so we go up 1, right 2. And if we notice, all of them have a slope of 1/2. So really all we need to care about is the type of line and the shading. But we should notice that they did add something extra, so we should too. So it's going to be a solid line. So it's either going to be this one or this one. So these two here are out, so it's either A or C. And we want greater than. So where are all my y's greater than? Well, that's above, so it's this one here. Then we'll scroll down and take a look at another one. This one says, which of the following graphs represents the system of inequalities below? Y is greater than x and y is less than x plus 2. Well, if we notice, most of them are graphed similarly. So this one here has a y-intercept at 0 and a slope of 1. And this one has a y-intercept of 2 and a slope of 1. So it could be this one. It could be this one, because those look identical with the lines. These two are not graphed correctly, so these ones can't be it. So it's one of these two here. And I want greater than this line here. So I need everything shaded above. So that would be this. So that part's good. And then I want less than the red line. So everything here. So this would be correct. This one would not because it's shaded above the wrong one. So it's this one here. So we'll go ahead and answer all of these questions until we get to the end. Once you get to the end of the assignment, go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.